Today, we are diving deep into one of the most incredible ideas in all of science, Einstein's general theory of relativity. Now, this isn't just some dry physics lesson, okay? This is the story of how a single powerful thought completely redrew our map of the entire universe.
So, let's get straight to the heart of the matter. For centuries, Isaac Newton's law of gravity was pretty much perfect. It worked for everything we could throw at it, and you know what? It's still insanely accurate today. So why on earth would someone like Einstein even bother trying to replace it? That's the big puzzle we're going to piece together today.
To really solve this mystery, we first have to appreciate just how amazing Newton's theory really was. This wasn't just some other idea in a textbook. For hundreds of years, it was the absolute foundation of physics.
I mean, just think about that for a second. One single, elegant law, written way back in the 1600s, could explain why an apple falls from a tree and predict the orbits of planets billions of miles away. We literally still use it to send rockets to the moon and beyond. Its power is just undeniable.
But, yeah, there's always a but, isn't there? Despite all that success, physicists started noticing something, well, funny about Newton's law. And not funny haha, but more like funny strange. A few little cracks started to show in this seemingly perfect theory, hinting at something deeply weird underneath it. All right, let's dig into that first major crack. And it all has to do with speed, specifically a cosmic speed limit that Newton's gravity seemed to blow right past. And this slide really lays out the whole conflict perfectly. On one side, you have Newton's universe, where gravity is an instantaneous force. If the sun moves, the Earth feels that change in its pull at the exact same moment. But on the other side, you have Einstein's new rule, which he figured out in his theory of special relativity. Nothing in the universe can travel faster than the speed of light. See the problem? These two ideas just can't both be true. Something had to give.
To really see why this is a total deal breaker, let's try a little thought experiment. Just imagine, for a second, that poof, the sun just disappears. Gone. What happens next?
Okay, look at this timeline. At time zero, the sun vanishes. Now, according to Newton, the Earth's orbit would change that very instant. It would immediately fly off into space. But here's the kicker. We know it takes a full 8 minutes for sunlight to even get to us. So we wouldn't see the sun go dark until 8 minutes later. That's a huge paradox. How could the Earth know the sun is gone before the last of its light has even reached us? This is that spooky action at a distance, and it completely breaks the ultimate speed limit of the universe.
All right, so that was problem number one, the speed problem. But the second one, honestly, is even deeper, even more mysterious. It has to do with the very definition of mass. Turns out, in physics, mass actually wears two completely different hats.
So, as you see here, there are two ways to talk about mass. First, there's inertial mass. That's all about an object's laziness, its resistance to being pushed. Think about trying to shove a bicycle versus a car. The car has way more inertial mass, right? Then you have gravitational mass. That's about how much gravity pulls on an object, basically its weight. In Newton's world, these are seen as two totally separate, unrelated properties of an object.
And yet, here's the super weird thing. Every single time we measure them, these two completely different types of mass turn out to be exactly the same, to the tiniest decimal point. This is why a heavy hammer and a light feather fall at the same rate in a vacuum. But for Newton, this was just a wild, unexplained coincidence. Why should an object's stubbornness have anything to do with how much gravity pulls on it? He had no idea. It was just a complete mystery.
So we've got two huge problems, right? The speed problem and the mass mystery. And this is where Einstein's genius just comes in and changes the game completely. He came up with a single, breathtakingly elegant idea that solved both problems at once. He didn't just tweak Newton's laws, he threw them out and said, what if gravity isn't a force at all? What if it's geometry? This is the first half of his world-changing idea. Einstein realized that massive objects don't create a force that pulls on other things. No. Instead, they literally bend and warp the fabric of the universe itself, a four-dimensional fabric he called space-time. That's just our 3 dimensions of space woven together with the dimension of time. The classic way to picture this, imagine a heavy bowling ball on a stretchy trampoline. The ball creates a big dent, a curve in the fabric. Einstein said that's exactly what planets and stars do to space-time. And here is the second beautiful part of the puzzle. Objects like Earth aren't being pulled by the sun. They're simply trying to travel in a straight line through this now curved space-time. Think about a little marble rolling near that bowling ball on the trampoline. It'll start to circle the big dent.
It's not being pulled, it's just following the curve. What we feel as the force of gravity is actually just the sensation of moving along these curves in space-time.
And just like that, this one incredible idea solves everything. Look at step 1. It solves the speed problem. If our sun vanished, that dent it makes in space-time would flatten out, sending a ripple, a gravitational wave, out through the universe at the speed of light. No more instant action. And then, step 2, it solves the mass mystery. Of course the feather and the hammer fall at the same rate. They aren't being pulled on by gravity. They're both just following the exact same curve, the same path, in space-time. Their mass is totally irrelevant to the path they take. The mystery is gone, it's just geometry.
You know, this solution leads to a completely new vision of what reality is. Einstein didn't just hand us a new equation for gravity, he gave us a brand new way to see the entire universe.
Before Einstein, we all kind of imagined that space and time were like a fixed, rigid stage, just a static background where the events of the universe, the cosmic play, happened. General relativity shows us that's completely wrong. Space-time isn't a passive stage. It is an active player in the drama. It bends, it stretches, it can ripple, it acts on matter, and matter acts right back on it.
And this is really the final incredible idea I want to leave you with. This huge shift in thinking, from a static stage to a dynamic actor, is what led us to understand things like the Big Bang and black holes and gravitational waves. And it leaves us with this really humbling question. If we were so fundamentally wrong about something as basic as the nature of space and time, what else are we missing? What other mind-blowing secrets is the universe just waiting for us to discover?